by the fourth dimension, I'm talking about time, but I'm not talking about the ages of anything. I'm talking about the nature of time and how that affects what we think about the world and perhaps theology. I'm going to start off by talking about the difficulty of defining what time is, present some theories of time, and then since speculative theology isn't really my area of expertise, I'm going to quickly just try to convince you of something you already believe about maybe a Christian view of time, that in essence that it really exists, that time exists. And then I'm going to tell you why the prevalent view in physics for the past 100 years is that it doesn't exist, explain why that is, and then try to work it back in to science by the end of the talk and show how actually using a real time in our modern physics could help us out and help us develop what we really need to make some major advances in quantum gravity. So starting off the question, what is time? It's such a trivial question everybody knows the answer to. Here's got some quotes that I've pulled up. My favorite is just the top one. A lot of people have already quoted Augustine at this conference, and people will quote him after me. This is my favorite quote. What then is time? If no one asks me, I know. If I wish to explain it to one who asks, I know not. And that's kind of the way it is. We think it's such an obvious question. I remember having a very similar conversation with my father on this. He said, what's the big deal about time? It's so easy to understand. And then as I started to talk with him, then, okay, well, yeah, I'm not sure. He came up with something very similar to Einstein's, which is time is that which is measured by a clock. But that's not much more helpful than acceleration is that which is measured by an accelerometer. I expect more from my students, so I'm a little disappointed in Einstein on that, but there's a reason why he said that. But Carl Sagan's quote is also a favorite of mine, that time is just profoundly resistant to simple definition. And I think that is important. People have been struggling with this for a long time, trying to understand it. The more you think about it, the harder it is. Especially these categories by John McTaggart, which everyone who talks about time has to eventually comment on his A series and B series view. It really wasn't until I've been thinking about them for a year or two that I started really understanding what they meant. He actually has A series, B series, and C series time, but most everyone ignores the C series time as completely unimportant, so I'm going to ignore it too. Let's start off with A series time, and A series time is the time that we normally think of that is the passage of time where we categorize events as past, present, future. Past events are past. They don't exist anymore. The present is real, and the future will be, but is not yet. And this experience of moving through time, of aging, is actually a real thing. The passage of time is real. That's called A-series time by philosophers who talk about this. Even physicists are starting to use this terminology. And so I'll refer to it, but also sometimes I'll call it presentism, which is a more specific version of this where, there are possible variations on this. And presentism says that all that exists is the present. The past no longer exists. The future does not exist yet. So the present moment is all that exists. And when we talk about the past, we're talking about things that were, not things that are in some other coordinate. So different. The alternative is B series time here, where time in a way exists, but it only exists as a way of categorizing or comparing sequentially events. So when we talk about past and future, that has no more meaning than talking about to the left or to the right. We can talk about one side of this room and the other side of this room. They both exist at this, simultaneously. Now, if we talk about time that way, then we're talking about the past and the future exist in exactly the same way, and there is no progression of past to future. That's just a trick of our consciousness. The flow of time is an illusion. All events throughout all of time are equally real, just like all parts of this room are equally real. And to talk about one side of this room being preferential to another side, or kind of we can move through the room, but it's our motion that gives us an illusion that we're passing from one place to another place. The places are all there. So that's B series time. And what you have in B series time is that a time that's no longer linked to change. This room, as it exists right now, is not changing. It's there. And so if time operates that way, there is no true change. It's just there. All events are already there. And when we talk about change, we're talking about, again, an illusion. This is sometimes called eternalism, or the physicists usually call it the block universe, because it fits in well with relativity, as we'll see. I'm going to come up with my definition, and I do this in a way just because this is the way that a lot of people talk about time informally, but it's also the way a lot of physicists, when they're not getting into the technical stuff, when they talk about times, they are using this definition, and so what they'll say is that time is an illusion, as I'll show you in a minute. Time is a quality of nature that allows for true change. So when we're talking about physical variations that can be described entirely by a shift in coordinates, just shifting my coordinate from here to here, then we're not talking about true change, and so we're not talking about true time. So this definition implies more than B-series time. We're talking about A-series time here. That's when I say real time. From now on, I'm going to be talking about A-series time. Okay, now how can you have something where there's an illusion of change? I don't know if this works on an overhead projection. It probably doesn't. I don't know. Does that look like that's moving to you? Oh, yeah, okay. These dots are not moving. This is not a little animated GIF. These are static dots, but there's an illusion of motion. And so this is just one way that people say, by analogy, you could have a static universe where there's an illusion of motion, illusion of change, but there is no real change. Okay, other choices we have to make about time. Those aren't the only things we have to think about. We have to think about is time symmetric or asymmetric in the universe. If you go work backwards through time, do the laws of nature work the same way, or is there some asymmetry? Are the laws of nature deterministic in that you can look at all previous events and determine specifically what's going to happen next, or is there an openness to the future? So there's that choice that kind of correlates with time because you categorize things in terms of past and future when you're talking about determinism. And then there's the relational versus absolute. You could define time in terms of relationships rather than relative positions, rather than points on a background framework. An absolute time. So that's another choice. Now, all three of these are strictly speaking independent of whether A-series time exists or not, what I call real time exists. However, there's just a way that a symmetric, deterministic universe lends itself more to B-series time, and time asymmetric, open universe would lend itself a little bit more to true A-series time. If you think about it, if there is a direction to time, if the passage of time doesn't exist, the question is where does that direction come from? It just seems arbitrarily imposed. Like saying that there's a direction from one side of this room to the other, a preferential direction, why would it be there? It's very hard to explain time asymmetry in a universe without A-series time. It's a little bit hard to explain openness to the future, or openness in any sense, without A-series time. Although it is technically possible, and I won't go into the logical arguments here. I want to kind of be brief, but I just want to put out that those are kind of lend themselves well to one view or another. Actually, these can work pretty well either way. So here's my speculative theology stuff, which I'm going to zip through quickly. First of all, it seems like there is a beginning, but there's a lot of different ways of reading the first few verses in Genesis to understand what that beginning means. And some people have recently really tried to read that as God created time, and that's what it's saying. But that's not explicit in these verses. It's a little bit ambiguous in Scripture what that beginning actually means. Now, Scripture is very clear about the eternal nature of God, but again, a connection can be made to timelessness that I don't think is specifically in Scripture. Time could be a part of God's eternal nature. I'll come back to that in a minute. Okay, it's also, I think, clear in Scripture. Here's kind of the favorite verse everybody uses, but there's lots of expressions in Scripture that hint at the fact that God experiences time very differently than we do. But again, that doesn't say that God doesn't experience time at all. It just says that God's experience of time is quite different than ours. Now, here's where I think it gets really clear that time is important when we think about our theology of God from Scripture. God is constantly enacting change in the world, and he's constantly doing new things. That's the language that's used in Scripture. I was reading a Christian fantasy series that was written back in the 70s or 80s. It was for a children's fantasy series, not too unlike Narnia series. And in this series, the author uses for their name for God, they call him the Changer. And I thought that's a pretty good way to refer to God in some ways, because God is changing. He does not change himself, but he is constantly in the process of changing things around him. God desires relationship with his creation, and biblically it's hard to construct some sort of geometric relationship between God and creation. That's not what our relationship is. And this is, I think, is a really significant passage in Scripture where Peter says, I should have put the whole verse up here, we are called to be partakers of the divine nature. So I have this part in quotes here, partakers of the divine nature. And then he goes on to talk about add to your this, and I should have this. At one time I had this memorized, but some of you I'm sure do. Add all of these qualities to your partake in God's divine nature. And one of them is perseverance or long-suffering. And what does that really mean? What does patience mean? What does hope mean if there is no time? They kind of seem to lose their meaning. And so I think that these are hints in Scripture, very strong hints, that time, some kind of time, is fundamental to the way that God interacts with creation, if not God's eternal nature in part of his divine nature in and of himself. Despite this, many theologians, including Aquinas, have argued for a completely timeless God, at least in some places in their writings. And they described God as looking down on all of history. And this is most compatible with a B-series view of time, where change is illusion. In this case, it seems that you have to get rid of change, a real change, or change becomes illusion. Now, sometimes we do this because we want God to be a master of all time. But God can be Lord and Master of the future, even if it doesn't exist yet, if he is creating the universe, or creating the future. If God created the universe, he can create the future. He can be in the act of creating the future. We don't have to say that he's looking down on the future. In fact, that lends itself towards deism. In fact, that's worse than the clockmaker God, because we don't even have a clock that's ticking along on its own. We just have a picture hanging on the wall, and that's about it. So if God's not deceptive, if we're going to commit to physical realism for similar reasons, we should commit to some sort of temporal realism, that at least in the physical universe, there's some sort of reality to the passage of time. It's not some cosmic trick. And there's a few theologians who agree with me, including good old Polkinghorne and Meister Eckhart, which goes back a ways. Just a variety of people. Again, this isn't my field of expertise, so I probably could have pulled out some better ones. Okay, now on to the physics. Space-time. Now, some of you may be familiar with all this stuff. Some of you, this may be kind of new, so I've tried not to get really technical in a lot of this stuff. But Einstein's theories of relativity were formulated using a four-dimensional space-time. And what we do is we take space, and when we draw images a lot, where we take space and represent it in along one direction, and we kind of collapse all the three dimensions of space this way, and then we have time going up this way, and we can draw, here's an event, and here's going forward in time or backwards in time. But the point is when you apply the theory of relativity to this, you get some amazing results. So here's what relativity implies, that measurements of the passage of time are reference frame dependent. That means depending on what reference frame you're taking your measurements from, you can measure the passage of time of another reference frame quite differently. The real important ones are these next two. Measurements of simultaneity are relative to one's reference frame. And here I've got a hypersurface of simultaneity drawn on here, where all the points along this hypersurface are simultaneous. But if I take this reference frame and start to accelerate it, this hypersurface tilts, and suddenly I have a different surface of simultaneity. So it all depends on what reference frame I'm in, what events are simultaneous. And so that's how I get order of events along these space-like world lines being reference frame dependent. If I have an event over here and an event over there, I can maybe see them as simultaneous in this reference frame. I can construct another one where this event happens before that event. I can construct another one where that event happens before this event. And because of that, people start to question what's going on with time. Relativity is a theory that's been experimentally verified millions of times over. Actually, we use the results of this theory every day if we use our GPS. It relies on calculations using relativistic equations in order to correlate signals from atomic clocks on satellites in order to triangulate your position on Earth. None of that would work if relativity was not correct, to some degree at least, to a very high degree, in fact. All right, so does relativity allow A-series time to exist? What's the default position in physics for the past 100 years? No, it does not. So here's all these prominent physicists saying that time cannot exist. Douglas Adams isn't a prominent physicist, but I just threw him in there. Lawrence Sklar, actually, if you're not familiar with him, he wrote the book on time. It's a very scholarly work that just has almost everything you want to know about space and time from a physicist's perspective. Even gets into philosophy a bit, and he just very straightforward way says that the past and future events have to exist just as much as the present. There's no question about it. Special relativity refutes those philosophers who say they don't, out of hand. And then Albert Einstein says the distinction between past, present, and future is just a stubbornly persistent illusion. Julian Barber wrote a less technical book about time. He called it The End of Time, and it's not about the end of the universe, it's about the end of the concept of time. He says time does not exist. Here, let me explain from relativity why it doesn't. And what he meant was A-series time. Change does not happen. There are all these physicists who are actually saying this. Now, do the majority of physicists actually go around saying this? No, because the majority of physicists don't ask this question. But the physicists who are examining time and thinking about it, this is actually what, if you read the literature, the majority of them are saying this. They're saying, well, yeah, time actually doesn't seem to actually be there. Okay, so can we say that this is the end of the discussion here? Well, and is this really true? Well, the one thing is for certain, relativity does not allow for a universal now, a universal present. If the theory of relativity is correct at all, which it sure seems to be, especially special relativity really seems to be, right, and even general relativity is very, very, very convincing. And they seem to suggest that there is no universal now. It just doesn't work, and for the following reason. Here you have planes of simultaneity for some stationary reference frame going along in time. Now you have some moving reference frames, and they have different planes of simultaneity. And you can see one's moving one way, one's moving another way, and these are all intersecting each other. And so you have this complete disagreement about what now is. There's no universal now. It doesn't exist. So does that mean there can't be a true present? Well, if we assume the principle of locality, which says that things are really only affected by locally, you can easily still maintain presentism, because the other thing in relativity, that this is the thing that my students always confuse when I'm trying to teach relativity, they think time dilation means that suddenly I feel everything start to get slower. No, in your moving reference frame, everything just seems normal. We call that proper time. Proper time is the time of a material object that are traveling along time-like world lines. So this are these world lines right here, where there's a definite past, there's a definite future. This is how material objects travel through time, and these are called time-like world lines. If you're on a time-like world line, proper time travels at the same rate all the time, 1 second per second, and that proper time doesn't vary with motion or acceleration or mass. It's only measuring the relative time relative to another reference frame where you get these weird variations. So if you stay local, you can preserve a now. But then how do you define past and future? How do you relate to other locations? It becomes a little complicated. But maybe this isn't completely the end of presentism. Okay. Is there a problem with block universe view? This is the universe. This is the view that time doesn't exist. Well, there's the time asymmetry problem. Roger Penrose has outlined, even though most of the time when I read him, it sounds like he believes in a block timeless universe. But he has some really strong arguments for the arrow of time being real, time asymmetry. Some people have tried to argue away some of these. The memory arrow is the one that physicists usually don't deal with. They just say it's a trick of our consciousness, and they say consciousness is not directly a part of the field of physics, so we'll let the biologists deal with that one. And they go on to talk about these. Entropy, a lot of times they try to explain away through initial conditions, but there are problems with that, I think, because you can make special initial conditions or imagine special initial conditions in a future time, and you don't expect to see this time arrow reversed. Entropy can fluctuate back and forth, and whether we see a weather system like the Earth is an open system. Entropy goes up, entropy goes down. And you have icicles form, icicles melt. Okay, so that's time reversible. But icicle forms, breaks off, and shatters into a million pieces. That's not reversible. So there's this certain processes that it doesn't seem like you can ever observe them in a time reverse way. And I think that still is pretty convincing that something's going on to create a true arrow. And then especially if you look at some of these others, I think the quantum, I'll be talking about the quantum one in a minute. I don't have time to talk about all of them. Okay, so the quantum one, the laws of quantum mechanics actually seem to be hinging on time-dependent phenomena. We have dynamical entities that evolve through Hilbert space in a time-dependent way. Here's the equation, the Schrodinger equation that describes that. You have deterministic laws in quantum mechanics, but when you talk about then making observations, those observations are both time irreversible and truly indeterminate within statistical boundaries. Now, that's the typical interpretation, and there are people who try to find ways around that. But the standard interpretation of quantum mechanics actually is trouble for the block universe. Now, one way around this actually, when you make an equation, a version of the Schrodinger equation for the entire universe, the Wheeler-DeWitt equation, and quantum gravity, you end up with absolutely no time dependence at all. But that's kind of problematic, and nobody's been able to get very far with this because it ignores the problem of defining energy without time. What does energy mean without time? And the whole process of trying to build the universe is you're looking at the low energy limit of equations like this. But the summary here, there appears to be true change that defies a standard B-series time descriptions. Okay, I need to speed up a little bit here. I'm going to run out of time. So summary here, I want to just point out here, all of science is built on what we can observe with our senses, and the sensation of time is fundamental. So if time itself is questioned, the foundations of science seem to crumble. So maybe that's worth considering. Also, falsifiability. It's hard to imagine disproving just a statement that something's an illusion, where with presentism you can imagine building a time machine or getting closed time-like loops. If you can create a closed time-like loop, then that would be a serious blow to presentism. And people are talking about that sort of thing, but we haven't seen them yet. And then you have the problem of who am I? Okay, so this is an ontological problem, and so there's lots of problems there. Here's my little sketch. Here's space and here's time, and my 4D block body in a block universe. I'm born here, I die here, and I have successive awareness as I go up. It's kind of absurd, but that's, I think, the absurdity of an ontological picture of who a person is if time is an illusion. And you say, okay, God judges me. Oh, God's out here seeing everything, and God judges me based on my hair only. It seems very arbitrary. So anyway, I got to go on here to what the crux of the matter here is, that we may be able to actually get somewhere by putting time back in. There's new theories of quantum gravity that may be able to preserve presentism. And this is kind of an old idea that's been around for a while, Bohmian mechanics, or Hiley's implicate order, which uses some different type of mathematics to try to describe fundamental ontology of nature in terms of something other than particles in a background space-time fabric. Now, I think it's a very intriguing idea. It's based on some of Whitehead's concepts. Now, and if you guys, some of you may be very familiar with process theology, and you hear Whitehead and you hear some of these things that I'm talking about, and you think, oh, what about process theology? This doesn't necessarily have to have anything to do with process theology, because we're talking about the created universe here. And so if we define the universe in terms of fundamental processes, that's going to be a very different way of looking at the universe than the way we currently do in physics. And it doesn't necessarily get into any of those problems of theological problems. In fact, it might solve some theological problems. So here's a quote by Carlo Rovelli, who's a strong proponent of a timeless block universe, and he admits that after general relativity, we're not really sure of what space-time is, and after the discovery of quantum mechanics, we're not really sure what matter is. Maybe neither one of those is fundamental, and maybe process is more fundamental. It might give us a possible solution. Lee Smolin has done a lot of good work at looking at this. He's one of the few physicists out there who take time seriously, and he's been gathering other like-minded people. He recently published a book. I haven't looked at it yet. It was just a couple months ago. Released a book on the reality of time, and he's done stuff in quantum loop gravity. But he also has argued for emergent laws of physics that change over time. There's a problem to that you may, if you have emergent laws of physics, you may just have a complete meta law that encompasses all of that. It really doesn't tell you anything about the reality of time. But he at least recognizes the problem, and he's really good at stating the problem. He hasn't really come up with a great idea for solving it yet, in my opinion, but he's been really good at stating the problem. The one that's more exciting to me is the work of Fotini Marcopoulou, and she has done some excellent work in something she calls quantum graphity. And what this theory entails is taking the geometric dimensions of space and time, both of them, and saying that they emerge as part of this dynamical universe that's evolving in a different kind of time, which she calls fundamental time. So she says there's fundamental time, which is the A-series time, and then there's the space-time fabric, which is the 3+1 dimensions that physicists usually think of. And those 3+1 dimensions are not fundamental, that they actually kind of crystallize out as the universe cools. It's a really fascinating concept. I want to show you quickly what that might look like. Imagine an analogy. You have a blob of liquid water, no geometry. You cool it, and you get all of this high geometry in an ice crystal. A similar process, you have the hot universe that has no space-time geometry at all, which is kind of confusing to think of. And you have microscopic quantum degrees of freedom evolving in this fundamental time. So you do have time, a fundamental time, but no space-time. And that cools into a universe where space-time and matter emerge as physical properties. So just in conclusion, I'll put them all up here. There are radically different ways to understand time, and over the past century, modern physics has largely dismissed the real passage of time as an illusion. Some theologians are tempted to do the same, but I argue that Scripture does not support a timeless universe or even a timeless God, and despite the natural timelessness of relativity, there's strong scientific arguments for A-series time, and that may be the key to developing the next unification theory in physics. So perhaps time can't be seen, as Julian Barber says, but nothing can be seen without time. Thanks. Okay, yeah. Well, normally on the macroscopic scale, you're measuring a motion of a pendulum or something against a macroscopic time. In fact, that's how you identify change, is you say it was here at this time and it was here at another time. Now, if you somehow make the background time less fundamental and say the oscillation is fundamental, then you could use that as perhaps a way to identify time. But then that's kind of like this idea that a process is fundamental rather than space-time and matter, which is the traditional way in physics of looking at things. Is you say matter and energy in space-time are fundamental, and that process is what comes out of that. But if you, there's. It may go beyond just pure definition because there may be a lot of other consequences to that. But yeah, there's underlying assumptions behind all this stuff. Yeah.
Maybe we'll go on the next talk. Thank you again.